Welcome to Texas Tech University Mechanical Engineering. This is for the manufacturing lab, and today we're going to talk about the mill. Now the lathe, you put the part in the chuck and the part turns and the tool moves. In the mill, the tool turns and the part moves. So on the lathe, I could take something square like this and turn it round on the OD, but over here I can't do that. Over here I have to mill along it, or mill it off, or drill holes. And we use this mill also as a drill press. We've got the electric motor on it, and we have how to start the spindle, how to stop it with brakes, and how to adjust the speeds, both over here with handles, which are low and high gear. And we have our quill, and our quill adjustment is to move up and down. It allows this to come down, is the quill, whether we're drilling or whether we're setting our height. And the thing about the mill is the mill moves in 3 axes, where the lathe only moves in 2 axes. Over here we move in X, back and forth. We have an automatic move on it that we can adjust the feed that it goes really slow, or we can take and rapid and go really fast. I'd move in the X direction. That's the power feed. We do not have a power feed on the other 2 axes. We have the Y, which is in and out, and we have the Z, which is up and down. Every one of these axes has a lock on it. And on the lock, that's it right there and right there. And that doesn't do 100% stop on it. It's enough of it so it doesn't move on its own. We barely unlock, we barely lock. That's the X axis. This is the Y axis. And these 2 over here are the Z axis for up and down. So once we have it set, and the axis we're going to cut on would be unlocked, but the other 2 axes we would snug. That way the part wouldn't barely move and we have a crooked cut. So we have different cutters on this, and the cutter is mounted in a collet. We have collets set up over here, and the collets, they have a keyway in them, and inside of our spindle we'll have a key sticking out. Those have to line up, and you have to pick out the ID, inside diameter of the collet, for what cutter you're going to use. Now, in using cutters, we have end mill cutters. We have 2 flute end mills, 4 flute end mills, and the number of flutes is dependent on what kind of material you have. The harder the material, the more flutes you want to use. Softer the material, the fewer flutes. So I have a 2 flute here because I'm going to be cutting aluminum. I have a 4 flute here that I'd be taking and using if I was going to run steel. In using the end mills, we have to determine, like we do on the lathe, our speeds and our feeds. Well, our speed over here is our tool. Our speed on the lathe is our material. If I'm running a 6-inch pipe over there, I'm going to be turning slow, but I'd never have a 6-inch cutter over here. So if I look at the diameter of this, I can go to the chart and set my speed. When I set my speed, whether it's a low range or a high range, by moving the handle over here, once I turn it on, if I'm in low range here, I need to go to low range over here. And in doing that, that makes the end mill turn the proper direction. Okay? When we run an end mill, all end mills and drill bits always turn to the right. Okay? It always turns this direction. Clockwise if you're looking down on the spindle. How to take the end mill in and out, there's a process on it. And we have a wrench back here that is also a hammer. It has a socket on it, just like a socket on for mechanic wrenches, but it also has a brass head as a hammer. And it goes on that bolt sticking up there, and that's where it goes unless it's in my hand. When I take and start the spindle, and this is turning, there's a nut on the top of the drawbar that's turning as well. And if I leave this up here and turn it on, it will fly off, break, could hit somebody in the head and hurt them. So this stays in my hand unless it's at home or I'm using it. And then it goes back to being at home. So I take and I put it on the nut. Well, when I go to put it on the nut, if my quill is down, the nut at the top has disappeared. It's not there. So I have to make sure it's unlocked, raise the handle all the way up, and lock the quill down. Now the nut is exposed up here. And when I go to do it, and this is real important, I put the wrench on there, and once the wrench is on it, if I don't have any force, it just turns. The way to keep it from turning is I put my hand on the brake. Well, neutral is in the middle, and it's a brake this way, and it's a brake that way. And that just holds against the belt up in there. So if I'm going to take and remove the end mill from it, I'm going to grab my wrench that I won't let go of, and it goes up here on this nut. I put it on the nut, and I hold the brake and loosen it counterclockwise. I release the brake, and I turn it and do it again. Now, it's loose. I don't unspin it 50 times. I barely unspin it, one turn. And I'm going to take and hold my hand on the end mill and use the hammer on my tool to take and hit that drawbar bolt. Now the end mill will come out. Then I'll put my tool up, because that's where it goes. And then I can take and put my hand for the collet and spin the drawbar and release the collet until it comes out. So, in putting it back in, I have to line the keyway up with the key that's inside. I can feel the button. I put it in there and turn it. I push up on it, and I get the drawbar started. Now the collet won't fall out. I put my end mill in. I don't go too low, and I don't go too high. I put it where the flutes are barely out. Push the whole thing up, tighten my drawbar. If I get it tight enough up here by hand, the end mill won't fall out when I let go. I grab my wrench, I put it on here, put the brake on, and I tighten it, release the brake, ratchet back, tighten it, and it only needs a couple of times and it's good and strong. So when I go to put my part in here, aluminum is what I'm cutting, and if I put it in my vise, it's going to drop all the way down low. And if I'm working on the top of it, it's too low. So to raise it up and hold it square, I can run different sets of parallels. And these are very accurate. They've been machined exactly to certain specifications. And some of them are skinny and some of them are wide. If I put the skinny ones in, it's too low. I need to work on this. I can take them out and put the taller ones in. Once I have it set, I'm going to snug this up just a little bit on the handle and take my rubber mallet and make sure it's down as it's supposed to be. Then I can tighten this up. Talk about climb cut and conventional cut now. As you can see, it's depicted on here. So try to understand what's going on here, and I'm going to try to explain it over here. So I'm going to start my end mill turning, and I always want to make sure the end mill is turning the proper direction. All of our cutting tools need to be turning clockwise. That's if you're at the top looking down, it's turning clockwise. So I see it turning to the right. Okay? And then I'm going to raise my table up. And I'm going to dial over until I touch my part. Take and dial this one about 100 thousandths. I'm going to start feeding the part across the mill, and it's going to cut. Now remember our example. for conventional cutting or climb cutting. My tool is turning this away and it wants to throw my part that away, but instead I'm feeding my part that away. And this is what it looks like. That's a conventional cut. That's the proper way to cut. If I'm taking a heavy cut, I must do a conventional cut. So now I'm going to come all the way over. It's barely cutting, but it's not under a load, and when I'm cutting heavy, I'm going backwards. The part is moving that way. The rotation of the tool wants to throw the part that way, and opposite is the way we want to go. It always helps to take and put oil on your part for lubrication, and it cools your part. When I'm done cutting, I turn the spindle off and apply the brake. Okay, so the next thing we're going to do is we're going to learn how to use an edge finder, a center drill, and a drill bit. So we have to remove our end mill. Grabbing the handle again, put it on top, using the brake, loosing in it, and we only go one turn. We hold the end mill and we hit it, remove the end mill, then we remove the collet. Then we'll get the right collet is for our edge finder, okay? And on the collet, we got to find the key and match it up with the key that's in here. And we hold it up and we barely start it. It's holding the collet. And we get our edge finder. And we hold the whole thing up and we tighten this by hand. If we get it tight enough, it won't fall out when we let go. Grab our wrench, hold the brake on. We go clockwise, we release the brake, ratchet back, hold the brake, and we put a wrench up. So now we have the edge finder in there. Edge finder works to find an edge. And you can see this bottom has a spring in it and it moves. We need to set the speed to that, and to set the speed needs to be about 1200 RPMs. So I'm going to start the spindle and adjust until we get to 1200. Make sure our axes are unlocked, and we'll dial into the part. And you see it wobbling, and once we start touching the part, it'll straighten up. And then it'll break out as I continue going. It'll barely kick over. And that's where I'm going to use my DRO. I'll lower my table, and I'll move it over half the diameter, which is 100 thousandths. And that means the center of my tool is even with the edge of the part. So if I'm going to drill a hole 1 inch back, I can read my digital readout. And there it is, set on 1 inch. And I can lock this, and I'd know where 0 is. So now that I know where 0 is, I'm going to remove my edge finder. Turn it 1 turn, hold the tool, hit it, pull it out, remove the collet, and then I'm going to go to my center drill. We use a center drill to pre-drill our holes, and the center drill and drill bits go in a drill chuck. Not an end mill, a drill chuck. It's made for drill bits. We have to find a collet that fits the drill chuck. That's the right one. We have to find the key. We hold up on it, we start our drawbar. It doesn't fall out. We'll put our drill chuck in there and we'll push up on it. Get our drawbar tight. If we get it snug enough, it won't fall out. It's good. Put the wrench on it. Hold the brake clockwise, ratchet clockwise. And now we have the chuck in it. As you can tell, it's way too low. My part's up here, so I'm going to use the Z-axis and lower it. Then I'm going to look at my drill bit. It's a 1/2 inch drill bit. Open up my collet. My drill chuck. Put the drill bit in, tighten it, use the chuck wrench, the chuck key, and tighten it up. That would be for my drill bit. And we're going to use the center drill first. Both of them are 1/2 inch in diameter. So I have to set my speed to a 1/2 inch. I'm drilling in aluminum, the aluminum column. I find a 1/2 inch and it says turn 1100 RPM. I start my spindle and I adjust it just a little bit to 1100. I have it set at 0, is 1 inch back. And then this is where I'm going to unlock the quill and use the handle to drill it. I'll put some oil on it. Lock the quill, turn the spindle off, use the brake, move it out of the way. Remove the center drill. Move it out of the way. Remove the center drill and put in my drill. My So I start my spindle, I crank back to 0. I put some oil on it. Release my quill. Lock my quill, stop my spindle, apply the brake. Move it out of the way. And you can see we have a hole in our part.